All right, so what we're going to do today, this is the part 2 of the lesson that we didn't get to, and there'll be more notes. I'll have to add those. They're not there, but they will be. So this one is like a throwback to one of the last units that we did of making sure you pay attention to where the answers are. But notice we have sine of A and cosine of B. These are not the same angles. And if you look at the numbers, there's no way they're even the same triangle. Now, this should have said where A and B are located. So if it doesn't say, and they're both positive, it's very safe to assume that this is in quadrant 1. It usually tells you what quadrant, but since they're both positive, it would have to be quadrant 1. So let me go ahead and show you how to do this. So you draw a triangle for each theta given. So our thetas are A and B. So I'm going to start with A, and I'm going to draw this triangle. Wow, that was supposed to be a little straighter than that. That's supposed to be a right angle. This is A, and sine is opposite over hypotenuse, so it's 5 over 13. Now I'm going to do the Pythagorean theorem to figure out what this other side is. So I have A squared plus 5 squared equals 13 squared. This is 25, 169. You subtract off A squared is 144. So A is 12. So I did all of that work to find out that A was 12. So if I do B, and these are not expected to be to scale, all right? So this is B, and I have adjacent over hypotenuse, and this happens to be a 3, 4, 5 triangle. If you didn't recognize it, you can do Pythagorean theorem and find out that our A squared or B squared, whatever, if this is A squared that you're looking for, then it's going to be 3. All right, so now set up the formula for what we're looking for. So for cosine added together, it's going to be cosine of A times cosine of B minus sine of A, sine of B. That's the pattern, right? So cosine of A, I'm going to go to A, and my cosine is 12/13. My cosine of B, going to B, it's 4/5. Besides, it tells you right here, cosine of B is 4/5. So times 4/5 minus sine of A, which it gives you that here, or you can go back to here, adjacent over hypotenuse, opposite over hypotenuse, 5 over 13, excuse me, times sine of B, which is 3 over 5. And just in case you want to know, I was looking back here, 3 over 5, going opposite over adjacent over hypotenuse. Now, before you get excited and go to cancel this, I have got a subtraction going on, and this is going to give me a common denominator of 65. Now, what's going to happen here is these will multiply, and you get 48 minus 15. All I'm doing is multiplying the top numbers here. Okay? And then you add across the top or subtract, and the answer is 33 over 65. Now, 3 will not go into 65, so I'm done. Neither will 11. There's your final answer. Okay? All right, next problem. You got the same thing again. Now, again, we should have said where this was located. They're both positive, so we're in quadrant 1. I should have had some of these in a different quadrant. I'm not happy with myself. Okay, so if this is A, we have 5 over 12, and if you do A squared plus B squared equals 12 squared, I'm at 144 minus 25. So B is equal to the square root of whatever this comes out to be, 119. Now that sounds terrible that B is the square root of 119, but it actually works out okay. So this is square root 119, and then I'm going to take a minute to find my B triangle. Here's going to be B. And I have adjacent over hypotenuse. And that's going to be a 3, 4, 5 again. So this time to find sine of A plus B, I have sine A cosine B plus cosine A sine B. So my sine of A is 5/12. Cosine of B is 4/5 plus cosine A, square root of 119 over 12, and sine of B is going to be 3/5. Oops, 3/5. Okay, again, I got a common denominator of 60. On this side, I have 20 plus 3 times the square root of 119. Now, this is it. It will not reduce. Don't go in and try to reduce this. Remember, this cannot be reduced because I can't take a factor out of the top and I cannot cancel add-ins. I can't do a V cancelization. If you're going, yeah, but I could V it. 3 will go into 60, 20 will go into 60. Yeah, you can't cancel them. Okay, if you cannot factor out the whole top, if you can't factor out the top piece right here, if there's doesn't have a GCF, then you're done. All right, and we're done. All right, going on down. Our next page that we're going to do, this one is verifying a cofunction identity, which we're going to be able to simplify this because remember where pi over 2 is located. Wow, it's located up here as long as you have straight lines there in your unit circle. This is pi over 2, and this point is out 0, up 1. And remember, this is cosine sine, all right? So I know my cosine is 0. I know sine is 1. I'm going to start filling in everything I know. So this is my A, and this is my B. So I'm going to say sine, and that's a minus sign, sine A cosine B plus, no, it's going to be minus, just kidding. It's a sign, so it follows the sign, minus cosine of A, and I've got these hanging up in the stratosphere, I'll tell you why. Sine of, whoops, almost wrote B down there, and I don't want to. Okay, whoops, didn't mean to do that either. Sine of B. Okay, so watch what I'm going to do. My sine of A is pi over 2. That's why I left it up there hanging, okay? And this is just going to be x, and this is pi over 2, and this is x. Well, remember I said there's my sine, and here is my cosine. So wherever I have sine of pi over 2, I get to put a 1 in there. So this is going to be 1 times cosine of x minus, now wherever cosine is, I put a 0. So 0 times sine of x. Well, 0 times anything is, dun, 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 0. And 1 times anything is that thing itself. So it's cosine of x. I'm done, and look, it verified. Yay! Here, we'll put a little heart. We got Valentine's coming up. Yay! All right. Let's look at another one. Okay, this one is a challenge problem. And I'm going to leave this for the 10 or 15 of you that go, I love a challenge. I want a challenge. Instead of me just giving you the answer, I want you to try it first. And I will tell you, it was a challenge even for me. I've got it. I've got the answer. I know how I did it. Somebody could come up with another method. I will give you the answer to this later. I think it's really cool, though. It's a very different kind of problem. And I will tell you, I got stuck, but then I tried something a little bit outside of the box, and it worked. And it's not outside of math. It's outside of the box of what I normally do. All right, so what I'm going to do is I am going to insert a blank page, new slide. I just want it totally blank. All right, and then what I'm going to do is go back and do some of the homework problems for you. Even though if you're tired of listening to me, you can cut me off. I don't care. That's your call. What I do want to do is show you how to do these tangents or cosines. I want to show you how this works. Let's start with number 2. This is in the homework. Oh, and there was a typo on your page. Oh, it's on the back page. I need to do one of those. Okay, yeah, I may be adding a couple more pages in or do them on a separate video. But just real quick, I'm going to do number 2, and it's tangent of 180 minus theta equals negative tangent theta. And all I'm trying to do here is verify. So what I want you to think of is 180 is over here. So this is negative 1, 0. And this is cosine, sine, and remember tangent is sine over cosine, and this will give you 0 over negative 1, which is 0. Okay? So tangent of 180 is 0. So when we go to fill this in, I'm going to fill in everything like just how it's supposed to be. So you have tangent 180 minus tangent theta all over 1 plus, these things change signs. This one matches. All right, 1 plus tangent 180 times tangent theta. All right, so filling in the pieces that I know. Tangent 180 is 0. Tangent 180 is 0. So if this goes to 0, that goes to 0, what's left on the top is negative tangent theta all over. The only thing left is 1. Oh my gosh, that's just negative tangent theta. Holy cow, that was crazy easy. The ones on the front page are pretty easy. On the back, I'm going to give you one that's got 2 typos in it because that way I can correct it as I go. Number 8, it has sine of x is equal to 3 over negative 5. Now, I'm going to try to correct this on the one that I'm going to post on It's Learning because it says 0 is, or x is in between 0 and pi over 2, which puts it in quadrant 1. If this is quadrant 1, this cannot be negative because it's sine, so this has to be a positive. First typo. Second typo, it says cosine of y is equal to root 5 over 2. Guys, that would just be the square root of 5. So this should be a 5. I'm so sure I copied this wrong. I typed this up, and I'm 90% that, yeah, my bad. So this is 3. Oh my gosh, I just realized something I forgot to do when I did this for the kids in first period. Minus y, less than y, less than 2 pi. So this is going to be, think about where this is. This is quadrant 4. Quadrant 4, okay? So now that we have that figured out, and I am going to go back and tell you something real quick. If this is given to you, and notice how the square root of 5 over 5 matches, it had to come from 2 over the square root of 5. If you will take it back to this, being non-rationalized, it actually works out a little nicer for you. So let's go in and make our 2 triangles. We have one triangle in quadrant 1. And this is x. All right, and we have 3 over 5. So this had to be a 4. Well, that wasn't too bad. If we have the next one, triangle with angle y, we said it had to be in quadrant 4, so it should look like this. Some of you may not be 100% on how to draw these triangles. If you're not positive, please, please, please ask me. So cosine is adjacent over hypotenuse. So that means adjacent is 2, hypotenuse is the square root of 5. And then I have to do a squared plus b squared. Well, if I do a squared, b squared is 2 squared, equals square root of 5 squared. Okay, so that gives me 4, and this gives me 5. I subtract 4. A squared is 1. So A is 1. This side over here is 1. It's a negative 1, and I just caught that. That is a negative, and I forgot to show that to the kids in class. Dagnabbit. Okay, so once I get this one, I have everything that I need, and I'm trying to find, I didn't copy it. Heaven. It is sine, I'm looking for sine of x plus y. So to find sine of x plus y, I need sine x cosine y plus cosine x sine y. And now I'm going to go back to this and I'm going to find my sine and cosine of x. So I'm just going to use this one first. I'm going to get them all filled in. So sine is opposite over hypotenuse. That's 3/5. Cosine of x is 4/5. And then I'm going to get my cosine and sine of y. So this is going to be, cosine is 2 over square root of 5. And sine is negative 1 over square root of 5. And I lost that negative for my guys in first period. Yikes, I got to correct that tomorrow. Okay, so then you just simplify everything that we have, okay? The bottom is going to be 5 root 5 all over 6 minus 4, if you're with me, okay? 6 minus 4 is 2. 5 root 5. Now what this means, we do have to rationalize. So times root 5 over root 5. You always have to rationalize, get that square root off the bottom. So 2 times the root of 5 all over 10. 25, I'm so wrong. Let's fix that real quick. 5 times 5 is 25. And you're going, whoa, wait a minute, where'd 25 come from? This 5 is here. These make a 5, and you multiply them and get 25. Final answer. All right, there you go, guys. I hope this is helpful. I did a couple extra problems from your homework. Have a good one.